In this video, we'll be solving the following problem. So let the roots of the equation x cubed minus 2x squared minus 3x minus 7 equal to 0 be r, s, and t. Our goal is to find the polynomial equation whose roots are r squared, s squared, and t squared. Before we begin, you may first try this one out on your own. Okay, so let's begin. So for this one, our strategy to be able to solve this one is to do what is most natural. If we have this to be the roots of this equation, then a good strategy is to simply set y equal to x squared. By setting y equal to x squared, we can eventually convert these roots to be r squared, s squared, and t squared. But this isn't immediately straightforward, because if we do this instantly here, then we will have variables wherein the exponents are not natural or not non-negative integers, and we don't want that, since for polynomials the exponents must always be non-negative integers. So let's leave this strategy first for now, and we first do the following. So let's proceed with the solution. So for this one, we begin by separating the terms with odd and even powers. So you might be thinking, why are we to do this? So let me put here a y. But the reason of that will appear later. So first, let's do this first. Let's copy our equation out here. Let's put it here. And then if we are to separate the odd and even powers, then what we can do is just simply move this and this to the other side. So by doing that, we'll obtain the following. So we'll have here x cubed minus 3x equal to 2x squared plus 7. Okay, so take note here that 7 is even power. We can treat it as even power since its variable is just x raised to 0. And then from here, let us factor this one out. So we'll have here x times x squared minus 3 equal to 2x squared plus 7. And then from here, what we can do next is we first denote this to be a star. And then what we'll do is we will be squaring both sides of this. So why will we do that? So let's write here, squaring both sides. If we square both sides, this yields the following following equation. So we'll have here x squared times x squared minus 3 squared equal to 2x squared plus 7 squared. And what do we have here? Notice here that in this polynomial equation, we now have x squared. We can now see x squared everywhere out here. So if we apply our strategy to set y equal to x squared, then we'll definitely obtain a polynomial that is indeed a polynomial. Or in other words, the exponents of the x variables are indeed non-negative integers. So this is the importance of separating the terms with odd and even powers. Because if we didn't do that, then observe that here, if we immediately proceed with our trick of squaring both sides, then we'll still have terms that have odd powers. So if we apply this substitution, we'll still obtain variables x with non-integer exponents, and we don't want that. So that is the importance. So the key again, separate the terms with odd and even powers, then square both sides, and now we have this. So once we have this, we can now apply our strategy. So setting y equal to x squared, we obtain So we obtain the following equation. So we'll have here y times y minus 3 squared equal to 2y plus 7. Take note here that the roots of the roots of this is still r as in t, because in equation, when you square both sides or whatsoever, the roots would remain the same, the multiplicity would just increase. So we are still sure that this one, its roots will be r squared, s squared, and t squared. All we need to do is to simplify this to make the equation look nicer, but you can actually stick with this one. So simplifying, we'll apply a square of a binomial. So we'll have here y times y squared minus 6y plus 9 equal to 4y squared plus 28y plus 49. Yeah. And then yeah, just further simplification, distributing the y out here, we'll obtain y cubed minus 6y squared plus 9y equal to the right side of the equation. So let me just copy that one. And then from here, let's just combine the like terms. So one can check, or you can check rather, that we'll obtain y cubed minus 10y squared minus 19y minus 49 equal to 0. And this will be our equation for this problem. So this is the equation that we are looking for. This is the equation that would have the roots r squared, s squared, and t squared, wherein r, s, and t are exactly the roots of this. So yeah, I hope you enjoyed that one. Usually the trick here is to use Vieta's formula, but this is another alternative trick which I believe is much more easier and much more straightforward than using formulas. So yeah, I hope you enjoyed that one. Comment down below if you have another solution for this, and comment down below what else problems you want to see in this channel. So yeah, that's it. Have a nice day.